That's the moment to start. Hello, Year 11s. Welcome to your first video on physics. So this will be the last video where we have a PowerPoint and you'll be seeing me in the top corner. Otherwise, I'll be in the bottom corner of the screen. So if I ever stop and I'm starting to draw something, I'll be up here. Alright, so we are going to be looking at forces today, and then that's it for this topic. We'll be moving on to the next topic. Not next week? No, not next week, the week after we'll be starting the next topic. Alright, so what is a force? A force is any action that causes motion to change. So uniform motion is a state of motion in which the body travels at a constant speed in a straight line. So something going whether that be a car driving by, you're pushing something, or you're pulling something in a straight line, uniform motion. Rest is also a state of motion at which the speed of the body is 0. It is at rest, it is not moving, there's no forces working on it. It's just there. Okay, so to change the state of motion of an object, a net force must be applied. So the net force is a force that is greater than the resting force of an object. You're going to ask me, Miss, what's that? We'll get to that soon. We'll cover Newton's laws. And one other thing that I didn't write in here is that forces are either pulling forces or pushing forces. Those are the only two types of forces that we see in motion. Alright, so next. So instead of describing motion with diagrams, graphs, and equations, we are now learning to explain the causes of motion. So what's making something move? What's going on to make that object move like that? That's what a force is. Some history. So Aristotle made the first observation of forces. Galileo challenged his idea almost 2,000 later. And finally, we have Newton, who gave us his 3 laws of motion, which is how forces work. We'll be going through them soon. But first and foremost, we have force diagrams. So force diagrams depict all the forces acting on an object. It can be balanced or unbalanced. There are figures on page 73. Yes, you need to know how to draw these. We'll go through the examples. So this here, we have an object, right? If you want to draw the forces acting on said object, next to the object, you draw a dot and lines for the forces. So for this object here, we have gravity pushing it down, and the fact that there is something it's sitting on something is pushing it up, so it's not sinking into said object. Okay, now if that object is moving, to draw a moving object, you draw lines behind it, like it's running, like you see in comic books. Okay, and now we have other directions, so it's either moving with the object or moving or pushing against it. Your D&D that you're going to do is looking at drag, which is an opposing force. Oh, you can see me now. Is an opposing force, so it's pushing against the thing. Alright, so what are Newton's 3 laws of motion? You should have learned this in year 10. I'll give you a minute to write out what you think they are while I erase this board. You need to get a better eraser. Alright. Oh, that is broken. Lovely. Okay. So, let's go through his 3 laws. I'm hoping you all have them written down. You should know what they are. Alright, so, first law is the concept of inertia. The first law states that a body at rest will stay at rest until acted on by an outside force. Continuing on to say, a body that has been acted on by an outside force will continue to move at a constant rate until acted on by another force. The quantitative measure of inertia is mass. Okay? So, after that first part, that looks chunky and a pain in the butt to read, what it's saying is, if you have something and you push it, it's going to, you can't see this, but this, I push it, is going to move until something stops it. In this case, what's stopping it is friction and air resistance. Okay? But if we were to do this in a vacuum, like space, and you just push something, it would just keep going and going and going and going and going and going until it hits something or it managed to get into the gravitational pull of another planet or a star or something. Okay? So this is what the first law of Newton's is, inertia. Something at rest will stay at rest until acted on by an outside force. Once it has been acted on by an outside force, it will keep going at the constant rate until it's acted on by another force. Okay? That's it. Alright, so the second law. is F equals ma. It is an equation, which, if you write this out, is force is equal to mass times acceleration. So second law describes the outcome when the forces become unbalanced. So mass and weight are not the same things in physics. I know we use them interchangeably usually, but in physics they are not the same thing. Mass is how heavy an object is, and weight is a measure of gravitational force exerted on an object from what it's on, whether it be a planet, a moon, or a star. The weight formula is Fw, so the force being in small w for weight, equals mass times gravity. So if you want to find out what your mass is, you would do your weight. So let's just make this easy and use nice round numbers. So you know that acceleration for Earth is 9.8 meters per second, -2. You know that? And let's say we had something that was, oops, that is not correct. That was 98 newtons. The unit for force is newtons. Okay? And we wanted to find out what its mass was. Mass unknown. So we go F equals ma. You plug in your values. 98 equals 9.8 times by m. 98 divided by 9.8 equals mass, which, if my brain has worked correctly, is 10 kg. Okay, so the mass would be 10 kilos. Yeah, there you go. You have the whole thing right there. So that is how you work out the mass of an object, or you can do the same thing if you know the mass. You can rearrange that to find the force or the weight of an object. Alright, next. Third law. For every action, there is an equal and opposite reaction. So when that comes to forces, it means if there is a positive force acting on an object, that means there is an equal negative force acting on the object in an opposite direction. So forces always come in pairs. You cannot have a force by itself. It simply isn't done. It does not work like that. Forces always come in pairs. Okay? And describes a pair of interacting particles is what the third law is. For every action, there is an equal and opposite reaction. Alright. Questions, once again, in your textbook, page 79 to 82. There is our example, sorry. We will go through them. Here. Alright, so on page 81, there is an example of a gun being shot. Okay? And the question is, a 15-gram bullet is fired from a 1.8 kilo handgun. The force exerted by the gun causes the bullet to accelerate at 1.2 times 10 to the power of 6 meters per second squared. Calculate the acceleration of the handgun. Okay? So, we have a coordinate system. So there's two things happening here. We have the first force of the bullet shooting out of the gun. We have the second force of the gun recoiling. So, first things first. First force is equal to ma and acceleration 1. First acceleration we need. So, force 1 is equal to the mass of the bullet. Okay, so we want that in grams. So it's in grams, we want in kilos. So it's 15 times 10 to the -3 times the whole thing by 1.2 times 10 to the 6, because that is the speed. Oh wait, hold up, before we even get to that, silly me, I forgot to write out what it is we're looking for. Okay, so F1 equals our unknown. Our mass is 15 times 10 to the -3 kilos. Our acceleration is 1.2. Whoops, not there. 1.2 times 10 to the 6 meters per second, -1. All right, so we have everything. We're looking for a force, we have a mass, we have our acceleration, we have our formula. F equals ma. Right. Now that we have everything written out, there, we can plug it in. So F equals 15 times 10 to the -3. If you want, when you do this in your calculator, put brackets around the two different things, because if you don't, you're going to end up with a phospholother of a mix, which means it's just going to be a really messy mix. So when you plug it into your calculators, it should look like this with the brackets. Do not forget the brackets, and make sure your calculator is in degrees and not radians. I'm not using angles at the moment, but degrees, not radians. Yeah. After that, take that out. Is 1.8 times 10 to the 4 newtons. Now, we have the right system is positive and the left is negative. That makes no sense. Why is that negative? What is the other non-causable? Never mind. Alright, so we have the force. So we know that our gun is shooting out the bullet with this much force. Okay? Down here. This much force. And we also know that there is a recoil. If you've ever shot a gun, you know that the sliding pot that pushes the bullet out has to recoil to bounce back. And that is equal and opposite. So that was negative 1.8 times 10 to the 4 newtons. Okay? There we go. We got that. Yeah, there we go. Alright, next. So we have the force that the gun is producing. Now we need to find the acceleration of the handgun. All this here is for the bullet. Now we need to find for the gun. Okay, so using our number 1.8 times 10 to the 4, we're going to erase all this to find the acceleration at which the bullet is moving. Okay, so our mass stays the same. We are still working with the bullet. However, we now have our negative force that we are using 1.8 times 10 to the 4. Okay, so now with the new information, we are looking for acceleration. We have this instead. So when we rearrange our equation, acceleration is equal to force divided by mass. We have negative 1.8 times 10 to the 4 divided by 1.8. Why are we dividing by 1.8? That makes no sense. Oh, because the handgun is 1.8. Never mind. So, our mass is not what the bullet's mass is. Our mass is the gun's mass. Forgot. My apologies. Okay. 1.8 kg. So we should have this instead. Right? And then now with this information, you do the math, and you should get the answer negative 1.0 times 10 to the 4. Okay, meters per second, -2. Do not forget your units at the end. Okay, alright. So that is basically how you go about doing such an exercise. Right. Any other examples we should go through? No, the rest are all just questions for you to read about.